Hey everyone, ever seen those cool, trippy, animated battle backgrounds in old school games like EarthBound and thought, how on earth did they make that? Today we're going to break down one of the simplest, but most powerful, tricks in the retro graphics playbook, palette cycling. With palette cycling, we can take a normal grayscale image like this, and combine it with another image to create cool effects like this. It might look like this is a huge, complicated animation, but the core idea is actually super simple. Think of it like color by numbers, but with a twist. Step 1. The picture itself, but it's not in full color. This is a grayscale image where the brightness of each pixel is actually a number, an index, from 0 to 1. So black will be 0, white's going to be 1, and then our gray in between, this could be numbers like 0.5, 0.4, and so on. This image is basically a map, and it tells us which color number goes where, but it doesn't actually store those colors themselves. And so just as another example, we have this circular gradient here, where our black is 0, our white is 1, and our numbers are arranged this way. And using this same technique, we can apply this to other patterns. Step 2, our color palette. This is just a tiny image that's usually 256 pixels wide and 1 pixel high, where each pixel stores one of our colors that we want to render out to our image. And one way to think of this palette is this is just an array of colors that we want to paint out. On this palette image here, we have 4 colors, and so if we treat this as an array, our first index, 0, will be our color black. Our next index will be red, and so this will be index 1, then we have orange, and then yellow. So for our color palette here, we really have 4 different colors that we want to paint onto our textures. And so you can think of this as our paint box with our available colors we can choose from. And so for our color palette, now we just need a way to take our number that we're painting, so our number from 0 to 1, and find out which color we want to paint. And so to create that map, we just need to take our number 1 and divide it by the total number of colors that are in our palette, and this will give us our bounds of our numbers for when we go to paint on our picture. So as an example, we take our 1, we divide it by our 4 colors here, and that's going to give us our numbers 0.25, 0.5, and 0.75, and then 1. With these indexes, what we can do is we can take our number from one of our pixels and then map it to somewhere in our range here. So as an example, if we do our pixel and it's colored black, our number is going to be 0. We're going to come up to our range. We're going to see that 0 falls between 0 and 0.25, so this is the color we want to paint out. If we do white, our number is 1, so we've come to our range. In here, we're going to paint out the color yellow. But now if we do somewhere in the middle, like here, where our number is going to be 0.6, we're going to look in our range, and so we're going to paint out our color orange. Down here where it's a little bit darker, our number could be like 0.3. That's going to be in our range here, so we'll paint out red. With that, we can take our original texture, we can apply our palette to it, and that's going to result in an image like this. So how does this work? This is where step 3 comes in, where we have our magic glue, our shader. Our shader is just a tiny program that's going to run on our graphics card. For each pixel on our screen, our shader will read the number of our grayscale map, so our number from 0 to 1. We'll then use that number to look up which color we need to paint from our color palette, and then our shader will paint that color in place of that original pixel. So our shader is going to do that for every single pixel, which is how we'll get this resulting image here from this texture. So depending on which grayscale image we use, we'll be able to draw out different things by using this logic. And so to see a few examples of this in action, we have this shader here that's going to load in these available textures. For our textures, we have 2 color palettes we can choose from, and then we have 5 different textures that we can paint onto. Right now, our shader is set up to just render out our original texture. So if we change our indexes here, we can see some of our textures that we have available to us. So right now we're just rendering out that original gray image. So now if we apply our paint by numbers logic, we're going to take our original texture, this one here, and we'll get this resulting texture here. And then we have our other grayscale images that result in these textures. And so what's really unique about this technique is just by changing our color palette, we can get different results. If we switch our palette from 4 colors to 8 colors, we can get an effect like this. And then if we switch out to a completely different color scheme, we can get an effect like this. Now for the cycling part, the animation trick. Before we look up the palette color, we add a tiny offset based on the time. So our indexes are 0 through 3 become 1 through 4, then 2 through 5, 3 through 6, and then 4 through 7. Once we go past the end of our palette, we wrap back to 0. So once we hit 4, we'll be at 0, 5 will be 1, and then 6 will be 2. This will have the effect of shifting our colors in our array. So we'll see for our black color here, we go up to index 1, then 2, then 3, and then we come back down to the bottom, and then we do this for all of our colors. That means the structure of the image that we're going to color to stays exactly the same, but the colors shift under it, creating motion with almost no extra work. Alright, let's build this in WebGL. We'll need two textures. First, our map texture that we're going to color to. Second, our palette texture, which is 1 pixel high, holding our colors we want to use. So currently our shader is set up to read in our texture and then just render out our pixels to our screen. So now for each of our pixels, first we need to get the index of that color from our grayscale image, and this will be our index value from 0 to 1. So we're going to do float index will be equal to our text color, and then for our grayscale images, we can use our red channel to get that value. Now based on this index, we can look up a color from our color palette and paint that out. So we're going to do a vector 4. We're going to call this final color. We're going to set this equal to our texture. Now this will be the texture of our color palette. So we're going to do U textures. We'll do 0. And now we need to provide our location. So we're going to do a vector 2. And now we'll use our index of our grayscale image. And then we're going to do 0.5. So we're in the center of that palette image that we're looking up. Now that we have our palette color, we can just render that out. So we'll do our out color is going to be equal to our vector 4. Our final color, we'll do our RGB, and we'll want to set our alpha to 1. Once we do that, our grayscale image should now be completely colored in based on our color palette. So now to do our animation or our palette cycle effect, instead of just looking up based on the index of our grayscale image, we'll want to convert this to a new index value based on how much time has passed and based on the size of our palette. So for that, we're going to do a float. We'll do U palette width. For my color palette, I have 4 colors. And now to calculate that index, we'll do a float. We're going to do animated index. We're going to set that equal to our index of our grayscale image times the number of colors in our palette. And now we want to add in our offset based on our time. So in our example, we have a uniform called hue time. And now we want to multiply it by how fast we want this to be. I'm going to add a new uniform, and I'll call this cycle speed. I'm going to define that here. I'm going to set that to 0.5. So our cycle speed, once we have our animation effect, that'll be how fast our colors are going to shift. So now for our index here, since we're multiplying it by our offset, we need to make sure once our index goes outside the bounds of our array, we wrap it back around. To do that, we'll make a new float. We're going to call this wrapped index. We'll set it equal to, we'll use mod. So we'll take our animated index, and then we want to do our palette width. And so our mod function is going to give us the remainder when we divide our index by our palette width. Finally, when we calculate our final color, instead of doing our index, we'll want to take our wrapped index, and now we need to divide it by our palette width. And then once we do that, we should see our new animated effect. And so by modifying our cycle speed, this will allow us to speed up or slow down the effect we're looking for. And then to create different effects, all we need to do is just swap out the textures and our color palettes that we like to use. Because the palette texture can be anything, fire gradients, rainbow stripes, wavy patterns, and because the map never changes, you can make a ton of unique animations just by swapping your palettes. And with effects like this is why games like EarthBound could have wild psychedelic battle scenes. And that's palette cycling in WebGL, a simple concept, tiny bit of shader code, and a huge visual payoff. In the next video, we'll plug this straight into Phaser 3 and make it game ready. If you enjoyed this video, give it a thumbs up and drop a comment with any shader ideas or effects you'd like to see next. And if you've been enjoying these Phaser tutorials and want to support the channel, I've set up a Ko-fi page. Even a one-time coffee helps me keep making more videos like this. You'll find the link in the description. Don't forget to subscribe so you don't miss future tutorials. Thanks so much for watching.